let's get to some coding. We want to start coding, right, with Solidity. So yesterday we did one experiment with a contract interaction in an application called Uniswap, and we saw that there is some sort of application, a smart contract, that somehow can make a currency exchange for us. Very interesting, right? This is using the power of something called smart contract. There is no backend there, no centralized services, all on-chain using smart contracts. Very interesting. So let's learn how to build one of those smart contracts today. Okay, Pedro, I saw that you raised your hand earlier. Do you want to add something or ask something before we begin?
I think you're going there. It was a question about the. I was just looking at the lesson and a question about the code, but I think we're going there. Yeah.
Okay, yeah, we are exactly starting that. Yesterday, I just dropped this code. I didn't explain anything. We just started scratching on the idea of using the remix as ID and all. I pointed you to the documentation just so that you get familiar with it. And today we're going to get through line by line. Okay, good. So if you remember well from yesterday, we did this transaction, we interacted with the smart contract, and somehow the blockchain was able to process this program for me. Let me show you what is happening. I'm going to use the Etherscan again. I'm going to view the last transaction that we did yesterday, and I'm going to use this application, Etherscan, to inspect, to navigate through what is happening, okay? We sent a transaction from my address to this smart contract using this amount of data, these blobs of data here. Let me view original here, okay? This input data that I'm passing is not a program, okay, people? It's just the parameters for calling this function. I'm passing a lot of bytes, yes, but this is not a program. The program is hosted here in this address. Yes, there is an account for hosting the code. We briefly touched that yesterday. And if we use Etherscan to go here for contract, and if we scroll down to the bottom of the page, we're going to see the byte code of this contract. Scroll. This is a big, okay, here. So this is the byte code. This is code. This is not just the parameter. This is actual code of the whole smart contract. Okay. Look, can you hear? Can you read this code? Okay, if you can, you are a bot out of the bootcamp. Only humans here, okay? Just kidding. All of the this bootcamp is very inclusive. Anyone can get in. Okay, so this is the byte code that I have for that smart contract. Okay, I have a question from Pedro and another question from Bami Go. Yeah, sorry if I misspelled your name. Ayodeji. Pedro, you want to go first?
Oh, yeah. It was just when you asked if I could read it. I'm like, I can read it, but I cannot understand it.
Ah, okay. So yeah, got your point. That is correct. Now we have a question from Ayodeji, if I got your middle name correctly.
Yes, sir. What's the difference between bytecode and opcode?
Yeah, the byte code that we have here, all of those hexadecimal characters, every 2 hexadecimal characters is 1 byte, and the opcodes are composed by bytes. So here we have a collection of a lot of opcodes, okay, in hexadecimal. So let me explain you how to use bytecode, okay? So starting, we are going to start with 6101 opcode, okay? And then we're going to use A0 and then 6040, 52. And we're going to look at the yellow paper and use these bytes and all. Imagine if we were to do that. I'm just kidding, okay, people? Don't get scared. Imagine if we would do that. It'd be crazy. coding the program itself for the EVM directly with the opcodes, like programming assembly, something like that, it is very difficult. There are people that do that. It's very performatic, very safe, but it is very difficult. So from the early days of Ethereum, people saw the necessity of creating a high-level language for people to code in high-level terms what they want to do. They want to do transfers. They want to manipulate objects in storage. What they want to do. So they create this Solidity language so that we don't need to write these bytes by ourselves. We would write the Solidity code, and then a program called compiler would transfer that human readable, understandable code to bytecode. And this is exactly what Remix is going to do for us, okay? I did not explain anything about the code itself yet, okay? But I'm going to show why we are going to do this code first so that we have the purpose in mind, okay? Let me just disable this annotation here. Be clear. Okay, now it's off. So we are going to get to this code, I promise you, yet today, but let me show the purpose of it first. This is a Solidity code that I have here in my file explorer, and there is a program here in this tab, a Solidity compiler, that is a off-chain program, a program that can run on our computer. It's not encoded, it's not included in the blockchain itself. This compiler is going to receive one input, that is a file, and is going to give me two outputs. One, it is an ABI, a binary interface, just for us to know the functions and what to call there and not. And the second would be the bytecode itself. Every time that I put a valid input, I get those outputs there. To get this working, I can compile, I can invoke the execution to compile this one input, this HelloWorld.sol, by clicking here. Or even more conveniently, I can click on this auto compile so that every time that I do a change in my file, it would auto compile again. And as a result, I have those two files here in the bottom. Scroll to the bottom, you're going to see these. The ABI, let me open my notepad, something like this. Okay, text editor, let me see. Yeah, I have a book open here. Let me open another tab. So this would be the ABI. Let me increase the zoom. This would be the ABI. This is just a small text file in the form of a JSON that would guide us on what to call in each function now. It's not the super important thing. It's just an interface. We're going to use that a lot in the step 2 of today's lesson. For now, just know that there is this ABI. And the most important part, the bytecode itself. Look at this. Yes, we transformed this human understandable, human readable code that we have here on those 10 lines of code into this bytecode, starting at 60, 80, 60, 40, the deploy code, and 52, 34, 80, blah, blah, blah. This is something that the EVM can understand. The EVM cannot understand Solidity. Did you know that? Solidity is an input for the compiler, and the output of the compiler is the bytecode that the EVM can understand and can use for doing those programs. So this is why we need to learn Solidity. This is why we need to go to this tool, okay? Pedro, you have a question?
Yeah, so yeah, about the ABI. So when we publish a smart contract to the chain, do we also like attached in a certain way to the smart contract? We also need to publish the ABI, yeah, so that people can see how to interact with the bytecode itself.
Yeah, we're going to see that on the part 2.
Okay.
The ABI itself doesn't get stored in the blockchain. You would
It's
publish it in
implicit. It's implicit.
Etherscan.
The
Yeah,
bytecode.
you would.
Yeah.
Yeah, you would publish it somewhere else in Etherscan or somewhere. But the bytecode itself, you post the
Yeah,
ABI.
it's executed by the blockchain.
Yeah.
Yeah.
Okay. And Ayodeji?
Yes, sir. The ABI, it is the same thing as API.
The ABI here, application binary interface.
Yeah, can we call it like API? Does it work like API?
No,
The normal API we know anywhere.
yeah, it's different. Those APIs, yeah, different things. Okay,
All right, sir.
good. We're going to see more about the ABI in the part 2. Okay, let's just go through the code here, and we're going to see how that reflects later. You have a question, Marwan? Am I pronouncing your name correctly?
Yes, Marwan. It's okay.
Yeah.
I see ABI. It's commands like Python commands.
The ABI is more like a JSON file. Let me show that for you. Like a JSON. So it has explanation of what should be received and sent for the smart contract. Okay, it's more like a JSON file, you see?
Yes, I see. Okay.
Okay. So to summarize, we pick one file in Solidity, we throw that to the compiler, and we have two products, the ABI and the bytecode. Okay. So now it makes sense why we need Solidity. And to recall yesterday, when we go for the Solidity documentation itself, to the root of the Solidity documentation, we have this explanation that Solidity, it is a language designed to target the Ethereum virtual machine. So it's totally different from all of those other languages that you find out there. For the compiler to understand Solidity correctly, you need to follow the language grammar. You need to follow all of the rules one by one. And those are not the simplest rules, not the most straightforward rules as you have in other programming languages, but it is what it is. As we get used to these rules, we understand why they are there, why people designed it like this, and things start to make sense in a while. It is common to have resistance against Solidity because of how different it is from other language. Okay, I had it. Most of the developers I know, they had it. But I assure you, after you understand those design decisions, why I don't have random number generation, why I don't have API calls, why I don't have all of these kind of things. The programmers are lazy. No, they're not. We're going to discover within this bootcamp that actually those things are constraints about the blockchain itself, about the architectural blockchain. Okay, so give yourself a few weeks. You're going to understand Solidity. You're going to things are going to start making sense, and you're going to see that some of the design decisions that are here are actually very accurate, and they're needed for how the Ethereum, how blockchain works. Okay. So let's start with the structure of a smart contract first, and then we're going to go for those grammar definitions. Every Solidity file needs to have a similar structure, a similar format, where we can declare the object itself, the information to target the compiler, the state variables, functions. We can put function modifiers, we can put events, we can put errors, struct types, we can put a lot of things in Solidity smart contracts. I'm not going to go over them one by one, okay? This would be extremely boring and exhaustive. We're going to see examples in the next 2-3 weeks that those examples are going to cover most of those features, okay? For today, I'm going to cover only what we need for coding this hello world that we have here, okay? So for Solidity source file to be valid for the compiler, I already need to have some definitions. First of all, I need to have the first line that I have here, this green line, I need to have a license identifier. It's not super needed. You can take out, you would have a warning or so, but it is very important to protect you and your code from unintended usage. So if you put the software license here, you would have limitation of warranty, you would have limitations of liabilities, you would protect like trademarks, avoid trademarks and all. So depending on the license that you put here, I'm not a lawyer for this, but they see a lot of projects using those open source license. Based on the license here, you could be you could be protecting yourself against possible legal problems or other regulatory problems that may arise. Okay, you do not need to worry that much when you are studying this, but whenever you're publishing and deploying smart contract, pick a good license, MIT or any other license that you would prefer, or even the unlicensed code that would be possible to use in some cases. Okay. So if you don't know these licenses by all of them, you don't know what they do. There are many licenses that you can pick here, GPL, Apache, and all. You can give a look on those and study what would be better for your project itself. Okay, that would be the first line of code. The second, mandatory for us to compile this smart contract, is the version pragma. That would define, they can and should annotate to define the version pragma to reject or to allow compilation with compiler versions that would possibly introduce incompatible changes. So you can specify, I want to make a Solidity file that is going to be compiled with this compiler version 0.5.2, nothing below that, and nothing above 0.6, for example. So this caret here would limit this version. Or I could do like this, from version 0.7 including to version 0.9 excluding. So I would have those ranges. I couldn't go wild here, from version 0.4 to 0.9. Okay, this is possible. Or you pick just one version. I want this to be compiled with the version 0.8.24, and that's it, nothing else. Okay, and then you need to use exactly that compiler for compiling that Solidity version. Then you have the maximum control over things, but the least compatibility if someone else wants to compose with your smart contract. Okay, it seems like a small technical detail, but you have no idea how many breaking changes. There is a whole section about that on the breaking changes here, because there are a lot. Like, there are a lot of things that change, even in minor changes, like from Solidity 0.8.19 to Solidity 0.8.20. They changed one opcode that changes a lot when you're deploying to one kind of chain, another kind of chain, EVM, blah, blah, blah. ZK stuff. So there are many changes in small versions that you need to be aware of when picking these versions. So this is why you need to put this second line too, just for specifying how the compiler will use this. None of these should get to be deployed in the blockchain. Those are more lines of code to communicate with the compiler program itself. Okay. Those two lines of code, they don't get to enter the blockchain. They are more tweaking the compiler itself. Yes, Pedro?
Yeah, so you just said something that they changed one opcode, yeah, which is like a lower level, yeah, to identify the type of operation. But what I'm thinking is one of the big points of blockchain is that it's immutable and append only, or better, append only. So when you publish a smart contract, it's there forever. So they never change like the lower level stuff. That will never change, right? So when I
Yeah,
publish the smart contract, it it has a given bytecode, it runs in a given way, it has an execution flow, whatever, and that execution flow will never change, right?
Exactly.
Okay.
It's just that the compiler is an off-chain program. So if you are compiling your contract with something, with a compiler in the version 0.8.19, your bytecode is going to have one way. If you are compiling with the compiling 0.8.20, the same smart contract is going to use push 0 instead of the operation stack of doing 0. And this push 0 is something that is compatible with some chains. Other chains that have those ZK rollups, they don't have this push 0. They actually didn't have it in the time, but then they added. So this little difference, every minor version might have one of those small little detail difference that can be a bomb out there. It's not that this smart contract is going to turn incompatible. It's just that depending on how you compile your smart contract, you can have a different version out there. Okay. I like to use the example of translation here. For example, you can take a phrase in English and translate it to Portuguese or Spanish or Italian in the current dictionary, right? And it's going to be correct. But if you use an older dictionary, like from 200 years ago, is the language the same? Portuguese changes a lot in 200 years. Maybe Spanish did too. I don't know. Italian did a lot. So depending on the version of the language that you use, the correct translation would change. It would use these kind of pronouns instead of these kind of pronouns, but the translation is still the same. The meaning is still the same. It's just that the version of the language changed, okay? Good, does that make sense? Ryan, you have a follow-up question?
Yeah, I had a question. What are the trade-offs? Like, are there any pros to using an older version of Pragma compared to a newer? Like, why would I not use the most recent, fastest or best version compared to why would I want to use an older version?
Yeah. So today I'm just explaining that you should annotate. I'm not explaining on the nuances of each versions, but since you asked it, yes, there are a lot of trade-offs. Okay, earlier versions they are not so. The oldest versions they are more battle tested. People have been testing them to see if they have bugs or not, and the newest versions they are prone to errors. They might have bugs, or so they are not so compatible. Sometimes you want to integrate a smart contract and then you want to inherit from another smart contract, but you can't because of version errors. So there's a lot of trade-offs here. Okay. We don't have time today for diving into those details, but we certainly are going to explore more of these down the bootcamp. Okay. So this would be the structure of a smart contract. But after we have the file structured, we can start doing all of those definitions. We can do state variables, functions, blah, blah, blah. And the grammar for it is defined here in the language grammar. So you can put, I'm going to show how to read those charts, okay? You can put specific definitions. For example, contract definition. You need to go like this. I'm going to show how to read this chart. You will start here in this line, and then you can use the word abstract, but not an option that you have. See the paths here? So in this smart contract, I decided not to use the word abstract, but I could. Here, abstract contract hello world. Okay, it means that this contract can be overridden. It's like virtual. Things can change. So I'm not explaining about abstract right now. It's just that we have this option according to the grammar here. And then we need to have the word contract exactly as it is, lowercase c, blah, 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 blah. And we need to pick an identifier for this smart contract. An identifier can be any word that you want. It doesn't matter the casing, can be lowercase, can be camel case. It doesn't matter much what kind of casing that we want. I can pick any word so long it's not a reserved word. So, for example, I cannot put contract constructor. No. Contract solidity. No. You see, so long I don't use a reserved word, I can name the contract whatever I want, okay? That is a style guide that guides us to use the cap words in contracts, but it's not needed for the compiler. It's more for maintenance. So this would be the contract and identifier. Then I can optionally define layouts of memory of variables. Actually, I can optionally inherit from all the smart contracts. We are going to see a bit of that tomorrow about this inheritance. Yes, a smart contract can pick a bytecode from order to start coding. And then I need to open a curly bracket like I have here. It is a need. You must do that, otherwise it is not going to compile. And then you can put contract body elements. For example, we can put a constructor definition like this. Constructor that need to have a parameter list. In this situation, it is empty. It needs to have a curly bracket here to have this block. I could put a modifier, I could put it payable, internal, public, blah, blah, blah. This would be a constructor definition. A function definition. It is huge. I need to start with function, lowercase, like this. Function in lowercase. And then I need to put an identifier, parameter list. Sometimes I try to say in one breath. Let me try. You define a function, you need to put an identifier, parameter list, and depending on the parameters, you will need to put the data location for each of those. And then you define the visibility from one of these options, and then you define the state mutability from one of these options, and then you define whether or not it's going to invoke some modifiers, whether or not it is virtual, or whether or not it's overriding another function. Then you would state what it returns. You would put a list of parameters, and depending on those parameters, again, you would maybe need to put the data location or not for these. And then you would close the parameter list, and then you would put the function block. I'm going to explain about all of those later. It's just that it seems a lot. If you have created a function in any other programming languages, this seems like madness. Wait, do we need to declare all of that code for an hour just before coding my function? Yes, because there are so many things happening under the hood here that even before you start coding your function, you need to tell for the compiler to prepare the EVM to access this state of the storage, or know to access this capability, or know how to invoke and how to control the flow of execution, blah, blah, blah. This is kind of a low-level code that is being handled in the function call, okay? We're going to see more about this today and tomorrow and also on Thursday. It's going to make sense, but for now, it seems like it's a little overwhelming, and I agree. It is a lot. But let's go through this, okay? We have this constructor function here. I'm going to leave it as it is because we're going to need it later. And we have this function definition. The parameter list here is empty. We don't need to pass any parameter for this function because our intention here with this smart contract is just to call it, and it should return hello world for us. This is a very simple experimentation that we want to do. So this function should return hello world when it's called, but when defining here in that smart contract, I have these many words to go through. So let's go over them one by one. Visibility. Whenever we are creating a contract, function inside a contract, I have 4 options for visibility. The external, you can see that in the grammar too, okay? The external, that would allow anyone from outside of this smart contract to call that function. Public, that would allow everything that external allows, plus internal function calls, okay? This is not about changing the state of things like a class, okay? A lot of people compare Solidity to OOP, sorry about that, the name blanket for me. Object-oriented programming, but actually there are some, you can call it, okay, it's not entirely wrong, but there are some differences, okay? Here, public doesn't mean that it can be changed, okay? Public, it means that it can be accessed. Someone can call that function either from outside or from the inside, okay? Internal would not allow external calls. Would be inside the contract. Any other function from inside the contract would be able to call it, but nothing from the outside of that smart contract, okay? And private is exactly like internal. It's just that it's not visible for derived contracts. For example, you inherit a contract from the other, it wouldn't see that private function. It would see all of the internal functions and the public functions, but it wouldn't see the private functions, okay? We're going to use that a lot tomorrow, so you don't need to worry that much with this right now. We're going to see state variables in the future. Just consider that there are no external visibility for state variables. It's just public, internal, and private, because it wouldn't make sense to have a state variable that is external only. I wouldn't have no use for that. So just remember that for the future. And that solves the first word. I'm putting public here so that this function hello world can be called from outside of this smart contract and from inside of this smart contract, which is good for me. Okay. The second definition, it is the state mutability. How many state mutability options do we have here? The answer is 4. They should have put here or whatever. It's like if you define a state mutability, you have 3 options. But if you don't, you have the default mutability that is non-payable. So actually there are 4 options. But the problem is that when you put non-payable, you still pay for the transaction. But yeah, I know. It sounds confusing. I'm going to go through that very, very slowly so that we understand this whole mess, okay? Let's start with the first 2 that are quite simple. Because I have yeah, function calls, and then inside the functions, I have the state mutabilities. Yes. So view functions, let's start with the pure functions actually. Pure functions, they promise not to read or modify from the state. They are much more like a constant, and they can only work with the message data that is entering and the code that we have there. Something that is static, okay? So I don't read from the blockchain. I don't use any data on the blockchain itself. I just compute something based on my inputs, or I just return a constant, okay? Yes, Pedro?
Oh, sorry, I forgot to lower my hand. But yeah, then these functions tend to be like idempotent, right? So for the same data, they will always give the same answer for the same
Yeah,
input.
yeah, it depends on where they are called. If they are called from another context, they might charge the user for the computation, okay? But if you call a pure function, sorry, directly, they don't make any change to the state. They are independent. So they return the same thing and they don't change anything, okay?
Okay.
And the view functions are similar in the extent that they promise not to modify the state, but they can view the state of the blockchain, okay? So you can get the balances of people, you can pick the block number, the transaction variables, a lot of things that are not able to be used in the pure functions. But you cannot do any of those things. You cannot write to state variables. You cannot emit events. You cannot create another contracts. You cannot use self-destruct. You cannot send ether. You can't call any other functions that are not market view pure. Like there are a whole set of things that are very cool that you cannot do. But at least they are free to call directly. You just get the information from the blockchain, okay? So here I'm using view. I have access to the state of the blockchain. And this function should not cost anything to call directly. Okay, let's stop here. Let's not go for the payable and non-payable yet, just so that we understand those two in detail, okay? I'm going to use a virtual environment. We're going to do this part 1 here to interact using a virtual environment, okay? As we proceed for this code reference here that we're going to do in a while. For now, just in understanding those two first, pure and view, okay? I have in this smart contract a return statement, and I need, remember, I need one of the things that I need to put in the return statement is a list of variables that need to be returned. Let me go to that real quick. So a parameter, type name, and a data location that could be memory, storage, and call data. I demonstrate that in less than 2 seconds, I know, but it's a lot of things for us to learn in one lesson, I know. So I'm going to defer that for tomorrow. Tomorrow we're going to see about this specific part. It is a string that is going to be dealt with in the memory. Okay, just take this as given as we focus in those two words here, okay? I know it can be a little stressful, but for now, let's focus on the state mutability. We'll learn one thing at a time. Tomorrow, we learn about this storage location, okay? So this is going to return something, and I'm going to put something to return. I'm going to return. Now, code with me if you want. Return a string, hello world. And then I should close with a semicolon. Okay. The compiler is pointing a possible optimization or error here in this smart contract. From what I have explained from view and pure functions, I guess you can deduct what it is. Want to take a guess? Pedro, do you know what is
I would say it's because since it's not accessing anything, why is it not a pure function?
Good call. Remember, I mentioned that view functions, they are able to access the state of the blockchain, the balances of people, the transactions data, blah, 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 blockchain data. But in this function, the line 9, we are not accessing anything of the blockchain itself. We're just returning hello world, regardless if we are in the Genesis block or in the current block, right? So this is exactly the suggestion, this warning that the state mutability can be restricted to pure. And that is true. Pure. Here, it's exactly what I want, okay? So just for us to know what is happening here, I'm going to connect my remix to a virtual environment, and then we're going to do this code block that is going to show those different functions. It is very simple, okay, people. We can just click on this tab, deploy and run transactions. And the default state of default environment for Remix is going to be this virtual machine blockchain, the most recent EVM that we have, the Cancun. And this is very convenient because when using this virtual environment, we have a collections of accounts with a lot of money on it already. Oh, 100 ETH. Let me withdraw. I'm going to buy a lot of food, or to buy a car, something like that. This is fake money, okay, people? It's not possible to withdraw here and buy things with it. It is just a virtual machine blockchain in your browser where you can interact with it for example, I can deploy a smart contract on it, clicking on this deploy button here. Okay, this orange button. And then I'm going to see the deployed contracts here in the bottom. I can just click on it to expand and click on the name of the function to invoke it. So it returned the hello world for me, you see. I have 99.999973 ETH. If I call this function 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I still have the same balance because this function is free to call. Okay. Now you have a question?
Yeah, so this is really easy to do using an IDE like Remix, but would you be able to do this from another platform, like not exactly similar to like an API call, but like do you have to use an IDE to call a smart contract and to call a function?
I'm going to show how to call smart contracts and functions from applications in next week, starting on lesson 5. Okay, it's going to be
Awesome.
easy too. It's just that you require some more tooling for this first week to keep it. We have a lot to study this week, so to keep it focused and to keep it easy, we're using this online IDE that is easy, so that we don't overload ourselves with things to pay attention to. So the first week is going to be using IDE. Next week I explain more about those tools. Okay. Yeah, but it's going to be cool. So just as experimentation, we can put this function as view too. If we put it as view, still I can compile that smart contract. It's not a big deal. It is still able to compile even though I have a warning. And if I deploy that smart contract now, still the view function returns the same thing and is free to call. Okay, so it's not because it's a warning that I cannot compile now. It's just that it's kind of wrong. I would be able to use pure, so why to use view? In this exercise, I'm introducing the concept of a state variable. This, let me copy this. You go here for the README. You're going to see this code reference with this string and this constructor. This feature of a state variable is creating a place in my smart contract, format this correctly, a place in my smart contract where I can store forever inside this same address where I have the code, the value of a variable. I'm going to set aside a space in the account. We're going to see that tomorrow. The account of that smart contract to store these collections of bytes. And I can set these collections of bytes to hello world in the constructor function. This is going to be executed in the deployment. It's not going to this code is not going to be invoked later when I'm calling the smart contract, just when I'm deploying. And then I can use the variable text inside other functions to dynamically update this value, this return value, and use that for function calls, use that as a parameter or as a component of my algorithm. If I do that, this state variable is now part of the blockchain. I cannot put it as pure anymore. If I try, I'm going to have this problem. What problem are we having here? The function is declared as pure, but this expression is potentially reading from the state, and thus it requires the view keyboard. Okay. So anything you require this state need to be in a view in a view context, or a non-payable or a payable context would be able to read from the state too. Okay. Pedro, you have a question?
Yeah, so I understand this is a simple example, but it already raises like a point, which is, so the string is private. It is just assigned in the constructor, which I assume if it's similar to other OOP languages, it runs once. And it's never reassigned, and I see like no setters for this variable. In this case, this variable can never change, right?
Yes.
Okay, okay. I know in other examples we'll make them change, but just to keep it
Yeah.
clear.
It is exactly the example that we have here. Now that we have just finished explaining pure and view, I can put this other function here in the smart contract, and now the variable is going to change. Okay, now I have a setter for it, a new text here that can set the value of this variable. Okay, and it receives one parameter. This is the first function or object that we have here that receives a parameter. So it's going to be a function called setText that receives one parameter, new text. It is a string stored dealt with in memory. We're going to see about that tomorrow. Name it new text. This function is public and is assigning the value of text to new text. Okay. And what is the state mutability of this function?
It's non-payable.
Let's see what is the default one. The default mutability is non-payable. Okay. People, right now you should be bookmarking all of these things, you know, and it is not necessary that you remember everything on the top of your head, but at least you should have those pages that you can go and search for the information. You know, I want to get you used to that because these documentations they change very often. So it's good of having this habit of going to the documentation and reading things directly there, because then you keep yourself updated. Okay, so when I ask, what is the state mutability here? You can look at that page. Okay, the default is non-payable. Okay, so I can put it here. Okay. Yes, Naya?
What's the difference between non-payable and view?
Non-payable and payable. Let me get to that. Non-payable and payable, they both can modify the state. They both can do all of these operations that are not allowed for view and pure functions. Okay. I'm going to get to that now. Okay, functions. We're going to see how they work right now. The parameters, we're going to get there exactly now. Okay, so in the state mutability, the view functions, the pure we covered, and now we're going to do the other functions, non-payable and payable. Let me show it working first, and then we defer those interactions. Okay, we are going to see payable for last. Let's start with non-payable because it's very straightforward. Let me deploy that smart contract here. Let me delete the older version that I had. Let me delete this one. And now we have this orange function. Interesting fact, the function is named non-payable, but you pay for the transaction. You don't pay for the function itself, but you pay for the transaction. So for example, if I write something here like ABC123, and then I click on set text, now, even though the function was declared before, hello world is declared in line 11, set text is declared on line 15, but even though, because I'm referring to this pointer in the memory, to this variable text, in this case in the storage actually, because I'm referring to this pointer in the storage, it was set to something here, stored in that variable. Now when I read this variable, it returns the new thing that I have put there. Okay. this is the non-payable. It can change the state of a variable in a smart contract. Okay. Yes, Pedro?
Yeah, so I have now a question about how this works with gas. We saw that for pure and view functions, we did not have to pay gas. But in this case, since we are changing the state of the blockchain, we have to pay because
Exactly. You pay for the transaction. You
so
don't pay for the contract, but you pay for the
yeah,
transaction. That is true.
so this is because we have to pay because since we're changing the state of the blockchain, there will be some compute associated with it to change the
Exactly.
blockchain state. Then our pure and view functions, if they are called like directly, and let's say it's not like a non-payable function calling a view or whatever, like they're called directly, do they run off chain?
Yeah, actually they run on chain, but you can evaluate directly with a node. You don't need to run the whole consensus. You go
Oh,
for a
okay.
node,
You don't have to do a
and then you
consensus.
get the
You don't
answer.
have to pay.
You
Okay.
don't need to run the consensus to agree on the new state. You just go for a node and you evaluate the execution of that function against the state.
So you have to just get a node to sort of tell you. You probably
Yeah.
will pay like in some other way, no? To just like through.
Yeah, or you can run a node yourself and do that
Yeah.
for free. Or you get access to a free node.
Okay. Okay. Thank you.
Okay. Good. Yeah, let's watch for the open mics there, people. So here in the chat, but that's good. No worries. So this kind of completes the explanation for this code that I have here. I'm going to do the part one. Again, just to recapitulate on what is happening. And then in the next 30 minutes or so, we're going to do the part two and part three to finish. Actually, in the next 25 minutes,
Sorry.
because I need 5 minutes to explain about this at the end.
Sorry,
We're
could
going
you kindly
to
scroll up for a bit? Sorry, I didn't raise my hand. Could you
we
kindly scroll up for a bit? I think there is
Lila, you have a question?
Sorry, yeah. Sorry, I didn't raise my hand. Could you kindly scroll up for a bit? I think there's a D or something missing in the code, but I'm not sure. No, in the other in the document.
That is?
Oh, sorry. Never mind. Never mind. I just thought I saw something missing. Sorry.
Okay, no worries. No worries. So we're going to do part one very quickly, just recapitulate, and then going for part two and part three for us to cover those background information that we are missing from linking the things that we saw yesterday with the things that we're seeing today. Okay, so whenever we connect to this environment, to this virtual machine environment, I can deploy the smart contract and start interacting with the functions. I can pick the state of hello world here. I can set the text. Set the text to something new, A, B, C, 1, 2, 3, 4, 5, 6. And then when I get hello world, it changes, but then I can put something else like potato, set a text, and then it's different. different. Sorry about that. Every time I'm setting the text, I need to pay. Let me show that for you. Picking another account here in this account dropdown. I'm going to pick the second account that I have access to, and I'm going to change this text from potato to tomato. And then I have here tomato, I paid. But if I select another account, like the third account here in my dropdown, and I just call hello world 3 times, I didn't pay anything. But if I call setX, even though it's non-payable, I'm going to change it for ABC, I still pay. I pay for the transaction. I don't pay for the function for the smart contract itself, okay? Good questions here in this part one before we proceed for part two. Yeah, Javier, you have a question?
Yeah. Can you hear me? I think
Yes.
Yeah, I have opened my Remix in my browser, and I have like a node right to the constructor and the function that says like infinite gas. So my question is, can we set like, for example, an amount of gas for yeah, those one.
Yeah,
So can
you
we
can
set
disregard this. Yeah.
can we set an amount uh, for a certain function or something like that, or is it default always?
No, yeah, you can disregard this. We're going to see more about those gas costing function calls by the 5th week or so. It's all related to the amount of computation that is going to be done. And since here we're using strings, and strings, they can have dynamic value, they don't know how to estimate the value. So it gives this infinite gas, you know. But in other functions, you're going to see that this is very well defined. So you don't need to worry with that. Okay. You can disable that function. Don't worry with that for now.
Yeah, thanks.
Okay, Conrad, am I
Hi.
your name correctly?
Yeah, it's correctly my name.
Okay.
I have a question. The string is private and the function is public is because is and the result is you can call from another account the string even
Yeah,
is private.
yeah. If I try to call this string directly, I can't. But if I call it from inside the smart contract, I can.
Okay.
See? It's like
Okay.
this. It's like your house. I cannot go there and pick your beer from your fridge, right? But I can knock on
Right.
the door and ask, "Hey, Conrado, my buddy, please grab a drink for me. I'm thirsty and it's hot out there." And then you go there, you pick the beer and give me. So there are those boundaries that you need to establish. I can interface with you on the front door, but I cannot enter in your house and pick the beer from your fridge because I guess we don't have this level of friendship yet.
Yeah, I got it. Thank you.
Sounds good. Any other questions? Okay, let's go for part 2. The only requirement for part 2 is that you completed yesterday's lesson. You have some testnet gas in your wallet because we're going to connect to this injected provider. I'm going to click in the list of environments. You're going to pick the first one that is the injected provider. That is going to use your MetaMask. The first time you do this, you need to approve the connection, blah, blah. It's going to use your MetaMask and it's going to use the balance that you have in your own accounts. Okay, so it's not possible to use free money here, like the virtual machine blockchain. You will need to have some testnet tokens. And here we're going to deploy that smart contract. Okay, the part 2 is interacting with these state change calls in public testnets, this first part, and we're going to see what is happening there, why the API is important, and how to give an introduction to what we're going to see tomorrow about the data locations. So it's similar on what we did yesterday on interacting with the blockchain with a wallet. When we click on deploy, we need to approve, just like we did for interacting with Uniswap yesterday. So I'm going to approve this transaction. I'm going to pay a little bit of Sepolia ETH for making that transaction happen. And when it completes, I have now this smart contract deployed to the blockchain. I can see it in my past actions and view it in the blockchain explorer. Okay, put it here. Close this. Let me close this. Here it is this contract deployment 24 seconds ago. So it deployed that smart contract to the real blockchain. See the real testnet blockchain. And I have some code there. Did we write this code directly? No, right? Who wrote that code, this bytecode for us? The compiler wrote this code that is now able to be interpreted by the EVM, right? So how to access the Solidity code here? It's not possible. I could even decompile, but the Solidity never gets pushed. I could have compiled this smart contract from Viper using Python. I could have compiled this smart contract from TypeScript with the interpreter with Rust. So no one knows what originated this smart contract. You can go from orange to orange juice, yes, but how to go from orange juice back to orange? It's very difficult. So this is what we have here. It's possible to decompile, it's not a big deal, but it is not a direct link. I don't attach the Solidity code to the smart contract, okay? And now every time that we interact with it, if it is a view function, like hello world, it's a view function, I don't need to pay anything. Why? Because the information is already there. Let me show that for you. When I deployed that smart contract, part of this deployment transaction that happened, all of those bytes here, part of this was for storing the bytecode, and part of it was for setting the initial variables. So I do two things at the same time, because I have some state changes here. One state change is the deployer paying gas. The other state change is the producing, receiving the rewards for mining or publishing this block. And inside this smart contract, I have placed a variable that was nothing to hello world, to text, inside the same transaction. So it's deploying the smart contract plus doing some pre-configurations on it. Those two things happens in the same transaction. So whenever I want to read this information from the blockchain, I just pick whatever is stored there. That is hello world. I don't need to pay anything. I just evaluate the state on the blockchain. Okay. But if I want to change it for something else, to potato, and I want to set this text, then I need to pay. The function is non-payable because I don't pay for the contract. We're going to see an example of a payable in a while. I don't pay for the contract, I pay the transaction for the blockchain. So I don't pay the contract itself. This is why it's called non-payable, but I pay the transaction fees, okay? You know, the namings here, they are not, they're not helping that much, but believe me, everything's going to make sense. If I do a good job, everything's going to make sense in a while. Okay, so this transaction confirmed. I can look at the list of transactions in that smart contract, or I can look at the list of transactions from my account. So this last transaction called the setText method. Okay, so it was a function called to setText. Okay, this was the parameter. This is a string. Believe me or not, this is a string. And I changed it from hello world to potato. If I look at the state changes, I'm going to have the payment stuff like the producer received the gas, the originator paid the gas, and inside the contract we had the change from hello world to potato. Okay, we're going to see all of this structure tomorrow. Today I'm just introducing the language that allows you to interact with these smart contracts. Tomorrow we're going to see more about the storage layout and blah, blah, blah. Okay. The interesting fact is I don't even need the code, the Solidity code for doing those interactions, because the opcodes are already stored in the blockchain. So even if I delete all of my code just by using an interface, for example, using this interface here, I'm going to explain about those more in futures lessons, but an interface is a contract that I don't have any definition on it itself, because I have it here, interfaces. So interfaces are contracts, are objects which are not objects. It's tricky. Abstract contracts similar to objects, but they cannot have code. They cannot inherit from contracts. All of the declare functions need to be externals. They cannot have state variables. They cannot have modifiers. The only thing that they do is to shape the ABI, represent the ABI of the contracts. And you can attach those interfaces to other contracts, conform them to those interfaces, or you can use them directly to interact with the blockchain. So in this example, I'm proposing this interface here, and I can even delete my whole smart contract and paste it only the interface. Okay, or you can attach the other, doesn't matter, but I'm going to do with this just to show the importance of the bytecode itself. And by having this interface here, it's not possible to compile a smart contract to it. I have my smart contract already deployed in this address that I'm going to send for you here in the chat. Okay, I'm going to delete this smart contract from my remix, so I don't have it anymore. And if I try to deploy this Hello World interface, I cannot deploy. I have this error because the interface, they don't have implementations. They are just a way to conform contracts to an interface, an ABI. So we cannot deploy it. But pay a lot of attention here, people. I can attach this interface to an address by pasting this address here. You see this box, add address. I can paste the address of the smart contract that I have just sent here in the chat and click in this add address. Even though I have not attached the interface to the contract before, just because it complies to that interface, the names are correct, the parameters here are correct, I can call hello world to get information, and I can even call set text to something else, like tomato, to change the bytes of the smart contract using this interface, even without having the Solidity code. I don't know how the functions work, but since I have it there stored in the EVM, I can change this string. I can invoke the execution of this. It finished processing. Now let me get to my address again. So the transaction worked. No, my address. Set text, yes. Where it is? Yeah, I guess not this transaction. What's happening? Yeah, this one, 38 seconds ago. Okay. So now I have sent this set text with this new string, the code, the data. It is the new text, tomato, you see? And the state is changing from potato to tomato. What I'm trying to prove here, that you don't even need the code itself. Once the smart contract is stored there in the blockchain, it knows what to do, even using just the interface, just the ABI itself. Remember, I mentioned that in the first minutes of today's lesson. The application binary interface can guide you on how to interact with the smart contract, even without the code itself, because it's specifying what to send, what to expect back, what are the underlying constants of that function, if it's view only, if it's pure, or if it's non-payable. So the ABI is already specifying all of that. I don't need to know what happens inside of the smart contract, so long I correctly attach to that interface, correctly conform to that interface, I can interact with it. Arda, you have a question? Am I pronouncing them correctly?
Yes. So how do we learn the functions that we can use interface for from an address?
Just with the address is very tricky. You would need to decompile the bytecode and do some inference. You still can get the functions there by decompiling, but it's not ideal. The best way is having the API. Usually you have access to an API that would guide you with the name of the functions, the correct parameters, and all of that. Okay. Good. Pedro, you have a question?
Yeah, so it's not about how it works, but more how it's used. So I got the difference between the ABI and publishing the interface and everything. But in practice, like let's say I write a smart contract, I publish the bytecode on chain, and I want to let people call functions there. Do I usually publish an interface? In practice, what do people do? Do they publish the interface or do they just post a JSON of the ABI? Because you can use either one of them.
A very common way is to verify your contracts in Etherscan. So when you go through the process of verifying your contract, this is nothing about the blockchain itself, it's just about application. You can, let me show that for you. You can submit the bytecode, verify and publish here. You can submit the bytecode for Etherscan, not for the blockchain itself, for this application called Etherscan. And then when the code is there, people would easily get what the functions are there and all, okay?
So
This is the
smart
most common way.
contracts are open source, yeah? You would say
Yeah.
so. Okay.
And also you would publish it to GitHub, you would put in your social medias, what are the GitHub links, you would advertise them, so it goes hand in hand. Because we don't want to trust entirely in Etherscan too. We can put in Block Scout, we can put in a lot of different places, the more the better, right? We can publish to IPFS, to Swarm, there are a lot of techniques that can help you propagating this information.
Thanks.
Okay. Good. Arda, you still have your hand raised if you have a follow-up question. No worries, no worries. Yeah. Just so having the bytecode, you cannot access to code. Am I right? Yeah, there is no directly link from bytecode to code. We can decompile. Yes, it's possible. It's not that difficult. It's quite deterministic, but nothing guarantees that that bytecode was indeed made from that code. Okay, it's like going back from orange juice to orange. Okay, it's plausible to say that this orange juice came from that orange, but could have been made with many other different oranges that would result in the same orange juice, you see? So it's not directly reconstructable, you see? Okay. And also we can attach interfaces to contracts just to make them conform to those interfaces so that I don't miss a function or I don't miss a spell, something, okay? It's like traveling when you have like your power adapters, sometimes it's 2 pins, sometimes it's 3, sometimes they are flat, sometimes they are round. So there are many different ways to get this going. Okay. This address is so that you can interact with this to Laurent. So if you want to test it around, you can send transactions for this address too and change the text, view the text. Okay, it's funny. Naya, you have a question?
What's the value of using an interface just generally?
Yeah, first you can use that to connect to smart contracts. You can build an interface to call that smart contract with function names and all. It makes it easier. We're going to use it a lot for that purpose in the next lessons of this bootcamp. But also to conform smart contracts. Let's say you are making a token and you want to conform it to the standard of ERC20. You can make the contract conform to the interface of ERC20 so that you need to have the transfer, the balance, blah, blah, blah. And this can guide you through implementing that smart contract correctly.
Okay, makes sense. Thank you.
Yeah. Good. So let's move forward for 5 minutes just to explain the payable part. It is a little more complexity, yes. Today's a heavy lesson, yes, but I promise it's going to be straightforward, like 5 minutes. We're going to see and we're going to understand, oh, this is what it do, okay. And then you put it in a box and put in your annotations for today. I'm going to go back for the virtual machine. We're going to pay for things with tokens, so I don't want to spend my testnet tokens that openly and without a purpose. So we're going to go back for this environment. Here we can use an abundance of testnet ether, and I'm going to make this function set text as payable, like this. This function set text being payable, it doesn't mean that it requires a payment. It means that it now is able to accept a payment. I could implement a feature to require payment, but this is a syntax for future lessons. I could require that the msg.value, all of things that we're going to see in the future, is higher than 1 ether, for example. I could code that myself, okay? Disregard that for now. This is syntax for future lessons. For now, just remember that payable is a way that I can enable my smart contract for receiving payments, okay? This means that now when I deploy that smart contract, my virtual machine blockchain here, not to waste testnet tokens, the function setText is now read. But it doesn't mean, like I said, it doesn't mean that I need to pay. Okay, I'm going to set text to ABC, and I'm going to pay for the transaction only. Okay, that's good. The balance of the smart contract is still 0. But now I can. Let's say I want to change for A, B, 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 C, C, C. I want to change the text for that. But I want to pay for that smart contract. So I can scroll up here to this value field. I can put 10 ETH as unit. So you type 10 here, select Ether. Your account should have that balance at this point. And then when I call this set text, it is going to set the text to this string A B B B C C C, but it's also going to store 10 ETH inside a smart contract. I paid for the transaction, and I also paid for the smart contract. One money goes here, the other money goes there, and this money is stored in that smart contract. I could program some logic that whomever wants to set a text need to buy out the text from someone else, something like this, just with these payable calls, like this here. Very expensive string here. Good that we are in a virtual machine blockchain, and this is not real money. If I use non-payable, I've said that several times, I still would need to pay for the transaction, but I cannot send money with it. For example, I want to change from HelloWorld to ABC, but I'm going to try and send 1 Ether. I'm going to try and send 1 Ether to this HelloWorld contract that is non-payable. It is orange here. It's going to give me an error. Look, this error. So I was trying to send money with this transaction. HelloWorld is still HelloWorld here, and it gave me an error because the function should be payable if you send value. I cannot force a contract to receive value by sending money to it. There are other ways, but not like this. So if I try to set text in a non-payable function, it fails. But if I try to set text with money in a payable function, it accepts. Okay. We have a question, Ayodeji.
Yes, sir. I'm getting confused right now. The other time you said the requirement to if the ETH your input is greater than one, so you're able to you should check if the gas your input is greater than one, you should proceed with the transaction. But right now you are not putting it there. So why is this failing when you put one ether there?
So when I put it as non-payable, look here, it's non-payable in this one at the bottom. It is failing because I cannot send payment to a smart contract function that is set as non-payable, you see? In the
Okay.
first option, when it's red here, I can. But in the second option, when it's orange here, I cannot, you see?
Okay.
Good. Okay. It is normal to have zero support ETH in your MetaMask. For you to have more money, you need to get from a faucet. So we saw that yesterday. So maybe you can go there quickly and get some MetaMask, some support ETH on your MetaMask. Yeah. Thank you. Thank Pedro Dante. So we saw a lot of things today, yes. And there are a lot of things that need to work for Solidity to work. There are some things that are more like design choices, some things that are more techniques. So how to get to know the things correctly, how to draw in the lines correctly. So I have separated two links here that are going to be very helpful. The first one is the style guide, just so you know, for example, naming conventions, order of layouts, and this kind of things, just so you know what is optional. So, for example, contracts and libraries should be written as cap words. This is a guideline, okay? If you write it all lowercase, it's still going to compile. This is not enforced by the compiler, okay? This is just to help maintaining the code, for it should be more readable, okay? You don't need to go over this today, but the sooner the better that you go over the guidelines, the naming conventions, and all, the better. And just by getting to know this style guide, then in the future, whenever you have questions about like the code layout, the order layout, what should come first, how to name those things, what names to avoid, what you should use. So you're going to get more acquainted with it. You can always review that. But the most important part of this guide is the NAT spec. There are certain documentations that you can put in a smart contract that they can be reused later for explaining things or even to explain the end user. And since we saw a lot of things today, I would recommend you to start documenting your smart contracts like this. So a function should return this, should retrieve this value, should return this stored value. Now, you can put these kind of documentations in any smart contract, and they are going to be ignored by the compiler. So they don't spend space inside the blockchain. They don't make your smart contract more heavier. And there are special ways for you to declare these, like with those triple fold slashes or with these code blocks. If you put those in your smart contract and put those annotations, it's going to be way easier for you to remember those things in the future, okay? You're going to have a weekend project with all the students, so you can share annotations, what you have annotated with other persons have annotated, and then you compare to understand what is going on. These kind of annotations can be really, really helpful. You just need to take a little care to know exactly how to put the correct documentations in the correct places, what you can use in the context of contracts, what you can use in the context of functions, what you can use in the context of interfaces and all. So give a read in this table. You're going to see it's quite easy, and you should be able to annotate all of your homeworks, all of your smart contracts in this similar way. Okay, the explanation about what the function is doing, the parameters that you should pass, the return values. If you put that in your smart contract, it can be quite easy for you and for other people to read that in the future. Okay. And that's it. That concludes all of the content that we have planned for today. If you have any issues or any questions, please feel free to reach out, put your questions there in the GitHub issues. You can reach out in Discord to give a read in all of those links that I have put in the reference. There are a lot of them, so read them all. Take half an hour or 1 hour if possible to read through them, and you're going to be prepared for tomorrow's lesson. Okay? That's it for today, people. I hope that you have enjoyed. Thank you all. See you all tomorrow.